So today was the beginning of Crash Course Physics. Go check it out if you haven't already. I've been awaiting this course for some time now because physics is the most challenging subject they've chosen so far. I mean, teaching physics is really hard, not just learning it. Most textbooks I've encountered just repeat the same old, boring, overcomplicated and sometimes even false stuff passed down from time immemorial. Now they've started with kinematics, which is quite nice entry into the subject. It shows a lot of the basic mathematical tools, linear, quadratic equations, that can be applied to many other quantities that change over time. However, there was one thing that has been sorely missing in this week's lesson. If you look at the second kinematic equation, unfortunately, they give no explanation at all where this formula is coming from. Why it is true, there's apparently nothing to understand here other than trust us, it works. But that's just not good enough for me. So here's a little extra showing you the story behind the formula. So there are two cases handled in this lecture. The first case is the one of constant velocity where there is no acceleration. So the velocity stays the same all of the time, and thus the position changes linearly over time. So x equals initial position x0 plus and whatever amount we have traveled, that is the product of the velocity v with time. Now the second case is a bit more involved. It treats acceleration, that is when the velocity is changing, and for simplicity let's assume that the velocity itself is changing linearly. So we have a constant acceleration from an initial velocity v0 to some final velocity v. The position as a curve therefore no longer has a constant slope but becomes steeper and steeper over time as its slope is velocity. And it's really not so easy to see what the change in position should be. But the basic idea is that however we travel, the change in position, the displacement, is just proportional to the average velocity v bar times t. And the average velocity can be found in the velocity diagram as well. It is simply the average between the initial and final velocity. And unfortunately, they don't really make a distinction between this average velocity and the final velocity v in their formulas. But this is very important because the average velocity actually contains a factor of 1/2. It is v0 plus acceleration times half the time. Now if we insert this into the kinematic equation for the displacement and expand the bracket, we get exactly the second kinematic equation. Thanks for watching.